This is an example of converting a game script into JSON. This example uses a grammar and the FAB tool. The point of this note is that you can use micro DSLs to storyboard and build parts of a final game or program. You can use tools to help you build up pieces of a game. For example, you already use a powerful programming editor to create parts of your game or program. You can use micro DSLs to focus on parts of your game or program to create a storyboard. I call micro DSLs SCNs for solution-centric notations. Then you can use tools like a grammar and the fabricator to convert the storyboard into actual code which can be copy-pasted into your game or program. There are many tools that you can use. You should use the simplest tool that you can get away with. For example, you might want to try using the bread tool before trying the workflow used in this note. Or maybe you can get away with just writing a Python program with regular expressions to generate code for your program. A goal to keep in mind is to automate the workflow so that all high-level storyboarding is done at the SCN level. Avoid potzing around with the generated code. I don't discuss how to do that here in this note, but this is a goal you should keep in mind. The way to stay out of trouble is to use the dry principle. Don't repeat yourself. Make changes in only one place. The reason that code comments don't really work is that they don't adhere to the dry principle. You can change the code and you can change the comments. Eventually one of them gets out of sync and the result is confusion and bugs. There are 3 inputs. One is the grammar. Second is the formatting spec. And third is the actual source code, which is a game script. This comes from a game called FABGhostStars. We run a command line and it generates some JSON. The grammar is in a file called grammar.ohm. It follows the rules of ohm.js grammars. It starts off with the name of the grammar, and then the first rule, which is in lowercase, which is significant to ohm.js. It says that we see 1 or more macros. And the macros are defined here. It could be a show phrase macro, a move phrase macro, wait phrase macro, fade to black, jump phrase, or something I've called lex spoken, period, a separator, a bunch of new lines, or anything else. The show phrase macro looks for the literal string show, defined further down as a file name, and then a literal string called at, and something called coordinate with a capital C. File name is just a name. It's lowercase. ohm.js does not skip spaces when it's parsing this. Coordinate is a number with a literal X followed by another number. And because this is capitalized, ohm.js skips spaces so we can have a number, any number of spaces, an X, any number of spaces, 0 or more, and another number. If we look down below, we see that a number is defined as an optional minus sign, question mark here means optional, followed by 1 or more digits. Digit is built into ohm.js. Likewise, the other interesting phrases are supplied as capitalized macros. There's the move phrase, which looks for the word move, followed by a file name, followed by the word to, followed by a coordinate, followed by a time span, which is defined further down. A wait phrase is defined as the word wait, followed by a number, followed by the word frames. Fade to black phrase is defined as the word fade, followed by the word to, followed by the word black, and a time span. Because the rule is capitalized with a capital F, there can be any number of spaces before the phrase or in between the components of the phrase. The final phrase is jump, which then looks for the word jump, followed by a chapter name. We can look down here to see how chapter name is defined and so on. The format of the fabrication rules is very similar to that of the grammar It has to have the same name as the grammar, open and closing brace, and then one rule that corresponds exactly by name to each rule name in the grammar. Parameters to each fabrication rule are valid identifiers in the usual JavaScript sense and can be followed by the plus, star, or question mark operators that we see in the grammar. The right-hand side of the rule is a string that is delimited by the open quote and close quote. Inside the string, you can have literal characters, and you can have references to the values of the parameters. In this case, the fabricator engine figures out that the parameter came in as a multiple match, one or more of, and expands the multiple match and glues it all together into one string. The top rule is called text, and it takes one or more macros. And for all of those macros, it produces this output string, a new line, followed by an open brace, followed by on enter colon new line, open bracket, a glued together string made up of all the macros that were matched, followed by the word true, followed by a close bracket, followed by a new line, followed by a close brace, followed by another new line. The fabrication rule for macro is quite simple. It says, whenever you match a macro, call it X, and then just pass it back up to the rule that called this, which is this rule up here. Let's take apart the show phrase rule. It says that it gets 4 pieces of matched patterns, and we're calling them kshow, file name, k@, coordinate. My convention is that for constant strings, I put a little letter K in front of it and give it a valid name. You can't put double quotes here as the names of parameters. After that gets matched, the grammar engine passes the matches down to the fabrication engine. These 4 matches here. The fabrication engine produces a string which is composed of a new line, an open bracket, double quote, image, double quote, comma, double quote, the value of the file name parameter, double quote, comma, and the value of the coordinate parameter, followed by another close brace, followed by a comma. The rest of the rules are similar in intent. If we look down here at new lines, we get a bunch of new lines, one or more new lines, and we do nothing with them. We just throw them away, and we produce an empty string. A single new line could have produced an empty string, but the way I built up this spec was that I produced the new line itself, the character, passed it back up to the NLS rule, and the NLS rule just threw it away. Likewise, the tab rule passes back up a tab, the period rule produces nothing, and the separator rule produces nothing. The actual source text is the game script. I've inserted these Unicode characters. They weren't in the original game spec, and they don't really need to be there. These Unicode characters just help me during development so that I can see what's going on. What we see here are phrases show prologue BG at OX minus 5/5 period. That phrase will be picked up by the parser. The first part is the word show, then comes a file name, prologue underscore BG, then comes the word at, then comes a coordinate, 2 numbers separated by an X with an optional minus sign in front. Here we've written in text and formatted it the way we want to. The grammar is careful to use lowercase rules at this point, which means that none of the spaces are skipped or squashed out of play. Now we're going to run the transpiler on the command line using the makefile. It first runs multi-git to make sure the repos are in place, and then it runs the actual fab command, giving it the appropriate parameters and an input of the source file that we saw. The output of the transpiler is JSON. We can also generate Lisp instead of JSON using the make run Lisp command. You see the format is slightly different. It follows the rules of Lisp, except in this one place with the question marks, where I just didn't bother to figure out what I wanted in this case.